In this chapter, we're going to talk a little bit about the time value of money. This is the mathematics of business, if you will. Let's think about making a decision. Let's say you want to retire in 10 years. How are you going to determine how much money you need to invest today to retire the way you want to in the future? Well, the first question we need to ask is, well, how much do you need in the future? And that's part of this challenge that we have with money. Money changes value over time. If you live on $40,000 today and you predict in 20 years you'll be earning the same amount of money, $40,000 a year in 20 years, will you be able to live exactly the same then as you do now? And again, that is the issue. That is the challenge that we have. When you think about making financial decisions are all about predicting cash flows in the future. And cash flows in the future are not worth the same amount as what they are in today's money. So let's think about some of the concepts here. First thing we have is something called a simple interest loan. Again, this is basically just the amount of interest you earn is based on the principal that you've borrowed. So in this case, the interest equals the principal times the rate of return times the time frame. So if you invested $1,000 for 5 years and you earned 4%, how much would you ultimately have to pay in interest? Well, $1,000 times the 5% interest times 4 years, or 5 years times 4% interest, you would only have to pay back $200. So the interest is based only on the principal. Now, most loans don't work that way. If you think about getting a loan from a bank for a car, or you're buying an asset, or just any kind of a personal loan, typically these are loans, they refer to this as a fixed principal commercial loan. I think a better term really, these are referred to as amortizable loans. That is, this is a loan that over time the loan gets paid off with monthly payments. So this actually are Fed fund rates, and they show that the federal funds rates in 2007 here was 4.5%. Discount rate was a little bit more, was 5%. And again, the prime rate, they refer to the prime rate, is usually set by the bank, but the bank will say, well, the prime rate is the discount rate plus X. So in this case, it's the discount rate plus 1.5, or 2.5, excuse me. 2.5 plus 5, 7.5. And you can go down the line to see what those are. Now, from time to time, they could change that interest rate. In fact, if you look here, they changed. In 2008, went from 2.5, now it's 3%. So they've changed the discount, or the amount that you pay that's different on the prime rate. Excuse me. There are things out there referred to as bridge loans. A bridge loan simply is usually used when you're buying a house. So you own a house, you're making payments, you have a mortgage on your current house, and you want to buy another house. Well, there is a challenge in getting the money to pay for the new house because you owe the money on the old house. So a bridge loan is typically a loan that you take on a property when you're buying another property. So for a little time frame, you will actually have two mortgages. This bridge loan typically is a simple interest loan. It's temporary, and whenever you close on the first house, when that money is freed up, then you ultimately convert the other loan into a mortgage, right? So this is just a way of gathering some funds for short term so that you can ultimately buy a house if you already have a house. Frequently, the banks refer to as discount loans. So what is the discount? It's the maturity value of the loan. It's the amount that you borrow multiplied by the discount rate multiplied by time, right? So in the end, the payback is the maturity value, right? So if a bank offered you a discount loan, how much would you receive? Well, let's just say it's a 8% loan for $3,000. So the discount, right, is 3,000 times 8% times 1. That's $240. So the loan that you would receive, the discount is $240. So you would actually receive $2,760. So let's see how this might work if you're calculating effective interest rates. So the amount that you borrowed is the proceeds divided by 1 minus d times t. And this basically tells us the amount that I need to borrow to get a specific amount. So I need $1,000. The discount rate is 8% for 1 year. So how much will I actually have to borrow? In this case, $1,000 is divided by 0.92. So you'd actually have to borrow $1,086.96. So what is the effective interest rate? You take the 86.96 divided by the proceeds times t, right? That essentially turns out to be 8.7%. What if it was you needed $2,000 for 8% was the discount rate, but you only needed it for 90 days? How would that calculate out? Again, you would need to borrow $2,040.25. The $40.25 is the interest that you would pay on this loan for 90 days. What is the effective interest rate of that? Effectively, the annual interest rate is 8.16%. So again, we can calculate the loans, we can calculate how much you need to borrow based on this concept of a bank discount rate. You also can actually lend money. You can lend money to the United States government. You can buy Treasury bills. And your textbook here says, what better source of investing than to lend the government money for a short period of time? Well, some people will question the sanity of lending money to the United States government. Even though you're certain you'll get the money, these are what are referred to as risk-free loans. Again, the discount rate, the rate of return on federal debt is very low. So let's continue on and expand our picture, if you will, and try to concentrate a little bit more on this idea of the time value of money, right? We've already talked about some of this, right? Financial decisions involve forecasting cash flows that are in the future. The time value of money allows us to compare from different time frames. Now, there are assumptions that we're going to make. We're going to have to assume we know what interest rate you're going to receive, not just today, but over the next 3, 4, 5 years. There's some challenges with that because you know, as well as I know, that interest rates change. So we have a question here. Which would you rather have? $1,000 today or $1,100 1 year from now? What's your answer? Which would you rather have? Well, we can't really answer the question because you need to know what interest rate you can earn on your money. If you could take the $1,000 and invest it at 20%, you would end up with $1,200. Obviously, that's more than $1,100. So if you could get 20%, you would take the $1,000 today. But what if you can only invest at 5%? $1,000 at 5% ultimately gives us $1,050. The $1,100 is a better deal. So we need to understand what happens to money over time. And again, this basically just goes through this description of how to do that. Now, this video that you can watch here basically is just a description from the Khan Academy. If you go ahead, it gives us a little example, if you will, of time value, how you calculate time value, and conceptually, what does this mean for making decisions? A more detailed analysis, though, of interest requires us to define different types of interest. We've already talked about what simple interest is, but let's look at it mathematically. Essentially, you get 5% of $100 every year on a $100 investment. $5 plus 100 gives you $105. The next year, since you only earn interest on principal, you earn another $5. So every year for 5 years, you're going to earn $5. At the end of the time frame, you will have $125. Compound interest is the way we typically assume money grows over a longer period of time than a year. So this compound interest says you don't earn 5% on the principal, you earn 5% on the balance. So 5% of 100 is $5 plus the 100. So at the end of year one, you have $105. Now it's 5% of 105. And then 5% of 110, 25. Then 5% of 115, 76. So in this case, with compound interest, you end up with another $2.63. What this means is that interest is earning interest. That's what's defined as compound interest. And mathematically, what we want to think about is, if you're thinking about investing, we want to think about putting money, investing it, in it moving to the future. How much will we have in the future? Likewise, if we know what we're going to have in the future, we would like to be able to bring that money back to make comparisons to the current time frame, right? So when you're thinking about business decisions, we're really thinking about both ways, right? You're thinking about getting money in the future. How much should you pay for a project? You need to understand what the future cash flows might be. Then convert those back in today so I can calculate them relative to the current cost. You might be thinking about retirement. How much money, if I invest X number of dollars every year, how much money should I have when I get to retirement? So these questions are all answered in the process of this time value of money. Now, there are several ways that you can calculate these values. You can do it with a formula. And as you see, some of the formulas, they're not all the most friendly of formulas. You can use tables. Sometimes you'll be able to find a time value table in a textbook. You can use a financial calculator, or in our case, you're provided with worksheets, spreadsheets from Excel that will help solve all of these questions that we may have about the time value of money. So let's talk about the variables. And just to think about how you solve these problems, time value of money problems are all about algebra. Of these variables, all of them except for one will be known. If you know all the variables in a formula except for one, you should be able to algebraically solve for the others. Now, we're using some exponential functions, so some of these may require some logarithms and natural logs to solve the problems. But again, if we know our algebra well enough, we can do this by hand. Much easier to do with a computer or a calculator. Present value is the beginning amount. PV 0, meaning 0 today. I is the interest rate. Frequently you'll see that as I divided by Y, which is interest per year. Future value, subscript N, is the future value sometime in the future at point N. That's N periods. Capital N is the number of years of the investment. A refers to payments. Again, sometimes you'll just see this as PMT for payment, but this is what's referred to as an annuity. It's a series of equal payments or receipts. Now, we can solve for the present value of annuity receipts, or we can solve for the future value of an annuity investment. Either way, we can solve for those problems. M refers to how many periods per year we calculate interest. Normally in business, we calculate interest monthly, 12 times per year. So M, for a lot of our problems, will be 12. But for simplicity, we'll start out thinking about M equal to 1, so that we have what's referred to as annual compounding. When we talk about monthly payments, then we're talking about monthly compounding. So let's take a look at our first examples. Let's think about calculating the future value of a single amount. Again, the future value is the value at the end of the time frame given some interest rate that we have specified. Again, we can use this, we can use a computer, we can use a table, you can use a financial calculator. We do have to consider, though, and remember that this is what's referred to as compound interest. The principal is the investment. It's how much you are placing somewhere today so that it will grow into the future. So let's look at an example. The present value is $1,000. The interest rate per year is 10%, and we're going to invest for 4 years. How can you figure out how much money you will have at the end of 4 years? Well, there's several ways you can do this. You can do the formula. Present value times 1 plus interest rate divided by y to the nth period, right? That is a formula that will calculate future value. If you have an interest factor table, you need to find the future value table, find out where n equals 4, IY equals 10, and that will help you calculate. You'll find this number, 1.464. Or we could use the computer. So our computer, time value of money is the worksheet we're going to be using. When you open that spreadsheet, you need to clear all the yellow boxes. The yellow boxes, if you remember, are our data boxes. And we need to input the data we know. Present value always goes in as a negative number. So present value is always negative $1,000. Future value, that's what we want to solve, so that's blank. Interest rate's 10%. Time in years is 4. And we've been talking about annual compounding to start. So annual compounding equals 1. So the future value is $1,464.10. So what I would suggest you do is maybe put your video on hold, on pause, get a financial spreadsheet and work this problem, work the other examples to make sure that you can come up with the same numbers as what I have here for these future values. So, if a wedding costs $20,000 today, how much will the wedding cost 10 years from now if inflation averages 4% a year? Let's plug that number in, right? $20,000 is the present value. 10 is the time, 4 is the interest rate. You should end up with a number of around $29,604. What is the future value of $100,000 if the money is compounded monthly at 6% for 18 years? Again, think about the information that you're given. Present value is $100,000. That's a negative number. Interest rate is 6%. The time is 18 years. However, we're now talking about compounding monthly, So that M, or that period per year, now is 12. So what will that be? And your answer to this question, if it only grew once per year, should be 149,083. But if you use the tables or the other thing with compounding, you should get a number of 293,680. So briefly, or very quickly, that is the first half of the time value of money. In the next video, we'll talk about going the other direction. Money that's in the future, let's bring it back to today, and we'll also have some applications to talk about.